Okay, so this is my answer to the first question. Discuss how the Frank-Starling law of the heart helps to explain the influence of venous return on stroke volume. Venous return is defined as the flow of blood back to the heart. The circulatory system, as we know, is a closed loop that is constantly flowing, otherwise blood would accumulate in other circulations, thus venous return equals cardiac output. This is backed by the Frank-Starling law of the heart because, again, it emphasizes the continuation of that balance. If the venous return suddenly increased, everything in turn would also increase, such as the right ventricle preload, and the same for the left ventricular preload. This would then increase the stroke volume, meaning everything in this equalized closed system would increase in an effort for the venous return to be once again equal with the increased cardiac output of the systemic circulation. Now the second question, explain the reasons for the observed changes in blood flow velocity in the different regions of the circulation. What is the benefit of the different velocities of blood flow? Changes in the velocity in different regions of the circulation reflect the cross-sectional area of the vascular tubes to be filled. Because the cross-sectional area is least in the aorta and greatest in the capillaries, the blood flow is fastest in the aorta and slowest in the capillaries. Basically, the bigger the vessel, the faster the velocity, and as the vessels slowly decrease in diameter, then the velocity, of course, decreases. And again, as the vessels increase, the velocity decreases. And one benefit of this is of the different blood velocities is when it comes to the capillaries. The velocity of blood flow needs to be much lower than it would be in the aorta because in the capillaries there's that huge exchange of gas and nutrients that's important that occurs. So yeah.